So, good afternoon. Client-side data compression is a new feature that was produced by a team of developers from OneCloud. I'm one of them. So, as you see, name of presentation, client-side data compression best practices. But there this practices goes from, not from users yet, from developers who know what inside of this feature and have some ideas how they could be used in the best way. So this presentation can be used as a reference for first users who will try to compress and get probably some unexpected results, and probably they will find answers to their questions here in this presentation. So first of all, there this feature is. So due to some delay of 2.17, we haven't placed it to a master, but we had an opportunity to release it as exascaler product part. So there was a technical preview. Then their first users can enable this feature and on their own risk try it. Then feature was stabilized yet, and first version was released. And right now we are actively working to release version 2, which will have some additional sub-features, something like Arch 64 clients, some additional heuristics, and statistics. So first of all, let's describe what this feature is and how it works. So obviously, this is compression that allows us to save space. But the main idea that compression is performed on the client side, because we have only some amount of servers, OSTs, MDS, and a huge amount of clients. And if we would compress data on the server side, it will be overloaded. In case then a client compress data themselves, less problems for servers. How this compression differ from just the case when we compress a file and place it to the file system? It has all features which Last.fs has. It's scalability, so any client can access any part of file. We have a lot of threads on each client and a lot of client. So it's fast, it's scalable. But because of this network nature of Last.fs, of course, this gives some troubles that should be solved. So it's not as easy as compress data on local file system. So I will give some information about these problems and how they solve it. Let's discuss a first case, which probably some users will face it. So it's from real early days practice. Then one of the testers tried to compress data, but they tried to compress data that already compressed. So obviously, compressed data cannot be compressed again. And the only result of such operation was that this performance dropped down. And question arises, why performance down? So the answer, you shouldn't compress compressed data. Probably to avoid such situation, we could add some means to skip such compression, and we did. I will show you later. So, to understand what happens inside data compression feature, let's discuss how data is stored. So, original file divided to chunks. Then every chunk compressed separately, place it to RPC, deliver it to the OST, and then on the OST they merge it together and place it to the storage. So as you can see on the bottom of this slide, finally less blocks are occupied. Because of network nature of Last.fs, there are some special cases. We cannot just overwrite part of the chunk on the client, because whole chunk is stored on the OST, and we need to have cache coherence between clients. So trying to solve this problem, we decided that recompression should be performed on the server side. So in case somebody rewrite part of the chunk, this part of the chunk is being sent to the server uncompressed. Their full chunk is being read from the storage. This chunk partially rewritten and placed back to the storage. Right now, this rewritten part stored as uncompressed to exclude this part, then server spent their CPU to process a client's requests. So in next steps, to understand the best cases, we need some means, some statistic, and such statistic were added. So there is server-side persistent statistic that can alive between Last.fs remount, and there is client-side statistic which live only after mount until unmount. Both statistics are useful, and I will show you how it's useful. Here is file that stored on the OST format, and some information that this information is stored to the OST every 10 minutes. It is being read during mount time and stored during unmount. File called compresstats. How to use it? It's easily. There is one command to reset the statistic, and there is a command that output the statistics. So here's example. There we write 1 megabyte and get statistic, and because source file is random stream of bytes, urandom, the result stored data size the same as original. So here we see how to see results of this operation and understand what happens. Client-side statistic work the same way. We can reset this statistics and get at any moment. So here another example, then data that can be compressed is being written to the file. We can see that 12 megabytes were written, and it occupies only 5 megabytes on disk finally after compression. So let's discuss some cases. So the best case for client-side data compression, then anybody writes compressible data using blocks that equal to chunk size. In this case, no problems at all. Every chunk compressed and stored to the storage. So we can see that after compressing 1 megabyte of zeros, we get 100 kilobytes of data on the disk. Somebody can ask why zeros not compressed to 10 bytes, for example, because of this chunk nature of compression. So all this 1 megabyte were divided to chunk, and every chunk of zeros are compressed to small amount of bytes. And here we can see that row size was 4 megabyte and result size is 70 kilobytes. And server side statistics shows how many bytes were finally written to the storage. It's a little bit more than shows client, because here this amount is rounded up to blocks. So unfortunately we cannot always write only comfortable data, because Last.fs users do what they want. And of course, client-sided compression support any cases, but they are less effective. So here is an example. Then we try to rewrite only 4 kilobytes block, and as was in one of the previous slides, in this case we need to send this block uncompressed to the server, read this whole chunk from the disk, change this 4 kilobytes and write it back. All these actions are logged in the statistics, so we see that user write 4 kilobytes, but finally to the disk was written 131 kilobytes, because this is chunk size. So a complete chunk finally rewritten on the place. And there is statistics about exact rewriting procedure. So back to the case and somebody trying to compress data that already compressed. So to avoid such situation, a heuristic was added. This heuristic checks whether we're trying to compress data that already compressed and how often we do this. So if at some point we understand that it is all file is compressed and no any reasons to continue try to compress, we just stop to try to compress and wait some time, some amount of data to try to compress again. So having these three options enough to customize this process. So we have one option when we should, how much data we should check before disable compression. This is called compress check bytes. Then another one sets how much data we skip and do not check after this moment. This is called compress skip bytes. And last one is reduce it ratio. It says how data should be effectively compressed to decide that this is compressible data. So change these parameters, give to administrator solve any scheme they want. And here is an example using statistics. Then we write in already compressed data, and all this data is marked as incompressible, and it occupies 3 megabytes of space. And then adding to the same file data that compressible, show us that some data was still skipped because of options, and then part of file was compressed, and finally we get 13 megabytes of the data. So so Last3Fast have a lot of features, and it's quite flexible for any case. And here there is possibility to decide how we compress data into different time. So assume some task writes a lot of data and want to do it a fast way, but still want to compress data. In this case, we can set some, we can choose some algorithm that give high performance, but probably not the best compression rate, and use it. So here is an example. Then we choose LZ4 fast with level 6, and result file is was compressed twice from 14 megabytes to 7. But if after this moment we want to compress even better, we can use just use LFS migrate to recompress this file on place. Just use another algorithm. Here is ZSTD with level 6, and here we compressed it to 6 megabyte from 7. So and some free time of client can be used for such a procedure. So here is a slide, thanks to Sebastian, that shows that there are already in client-side data compression, there are a lot of different algorithms which have different performance and different compression ratio. So a user can choose a fast one to compress, then a lot of actions, and then recompress to the with algorithm that compress better, but do it slowly, so it's flexible to user. Another example, again, Last3Fast is such flexible that allows us to set some scripts. Then we start a file with one options and then change them to another options. Assume then file is small. A lot of clients are trying to access it, and then file is larger, then it store it and access not so frequently. So we can divide this file to the ranges and use progressive layout and set different compression options to these ranges of data. Also, it is important that we change not only algorithm and level of compression, but chunk size, because the larger chunk we use, the better data is being compressed, but more overheads than we're trying to rewrite part of this chunk. So here we use 64 kilobyte chunk for small file, and then it become bigger. We increase the chunk size to 1 megabyte. So I mentioned that Arch clients are supported too, but there is some difference that such clients can have 64 kilobyte page, memory page, and users should understand that having different page also have influence to compression behavior. So here I should mention that then part of memory page is being rewritten. This special case happens, then this partial page should be written from the server and change it on place. So one additional step, and statistics shows that a little more bytes finally written than expected, but it's reasonably okay. So also these things should be considered. First of all, client-side data compression use buffer on the client, so data should be buffered. So direct I/O not the best choice for data compression. And right now, if somebody use direct I/O with compression, then the I/O switch it to buffered operation. Also, client-side data compression use spare files. Finally, we have holes on the OST. So right now there is no way to distinguish whether it was a spare file originally or this is compressed file. And so now, in case somebody trying to use f-allocate, f-allocate is disabled or compression disabled. This behavior sets a special option. Also, it is expected that network traffic will be saved somehow, but right now it looks like Alnet is not ready to send these holes effectively. So now, right now, these empty holes are sent too. So probably this will be fixed and network traffic will be saved too. Also, currently we save, after modification we have uncompressed data, I mentioned before. Data on the MDT is not supported but expected to be supported. Encryption currently is being disabled when somebody tries to write compressed data. T10PI is not integrated yet, but in process. And GPU direct feature is cannot work with compression because GPU access this memory themselves, not case for compression. So as conclusion, I want to give these advices to first users. First of all, compress only data that can be compressible. Use full chunks where it's possible. Use compressibility heuristic to skip data that cannot be compressed. Use buffered operation, because if you use direct I/O, it will be switched to buffered operation anyway. Also, we tried to use this feature with HDDs, but it looks like because of a lot of seek operation and the fact that we merge data together, this breaks a lot of optimizations. And finally, for HDDs, compression is not optimal. So it's better to use flash-based OSTs. And always should be understood which other features, last reference features are used to gather this compression. Use migration, progressive layout, and do not forget that algorithms have levels and there are a lot of different algorithms for any case. That's it. Thank you very much. Questions?
Thank you, Artem. Is there any question about data compression?
So Artem made a comment about LNet also transferring the holes. That's only on reads, but writes it doesn't send.
Okay, only on reads.
The unused part of the file.
Hey, Artem. It's a related question, actually. Could this be used for a different framework? For example, client-side checksums. We have quite a few very large customers who request checksums be a part of like the extended attributes.
Text? I'm sorry.
For client-side checksums.
Checksums.
Yeah.
So there is checksums support already. So and it still works as before.
So you just put like just a null encryption and take benefits. Is that it?
Andreas knows.
Okay.
So first of all, wouldn't be null encryption. It would be null compression. But in fact, we need to compress a little bit to store like a header that describes the compression type and all of those things, and stores the checksums in with the data. So you'd have to be able to compress at least a tiny amount in order to be able to store the checksum in there. Pardon? Yeah. So, I mean, presumably you would be able to compress that data some amount. Otherwise, why would you do it, right? But
it's the Zenziacs, the video. So this bit for Zenziacs, so the basically compressed videos already.
Okay, I mean, videos typically have their own data checksums in them anyways, so that's kind of pointless. But so the checksum is only to checksum the compressed data, right? So it's not going to be able to like reconstruct it or anything like that. That would be erasure coding or something. So, I mean, for video files that are already compressed, they already typically have inline data integrity checking, right? So that they can see when the video's gotten corrupted, but you would have to be able to do some compression, and so in that use case, you can't add the extra checksumming in.
Also, we want to add that compressed data have its own checksums. It depends on algorithm, and we have additional checksum that can be enabled for chunk. So, as of DiskFS tradition, some low-level utilities can check later, probably.
Was there a question? Thank you.